In this lesson, we are looking at our Math 2 MVP curriculum, Unit 6, Lesson 3, Ramp It Up. In this lesson, we have been asked to perform a couple of experiments looking at a water slide that Family Kingdom Amusement Park is wanting to create. And they need it to be safe, so they have some certain figures that they need to look at. And one of those figures is looking at what happens if they keep a standard height of the ramp and change the length of it. So the experiment can be done with actual ramps, but this experiment has been completed in Desmos just for the ability to record a video. So here we have our data, and we have a ramp height of 5 units. So imagine that you've got some kind of table that is 5 units high, and off of that table we have ramps of varying lengths, okay? And what we're looking at is as we drop a ball from that same height onto ramps of varying lengths, how long does it take the ball to hit the ground? And what you should notice from our data is that as the height or the length increases, you should notice that the time also increases. Okay. So as the length increases, the time also increases. Notice that this is a pretty linear path. It's not perfect because there is room for human error in the calculations, but what we know is that this is going to be a direct variation. And that is because the length increasing directly determines that we have more time since our height has not changed. Now going to our next experiment. In this experiment, the length of the board doesn't change, but the height changes. So we have a standard length of 120 units, but we're using that same ramp at varying heights. But the ramp length is the same. So imagine that the ramp might be here, but then as we get lower, that ramp is getting kind of flatter and flatter as it goes out. What ends up happening here is that as that ramp height gets higher, the time it takes to get down the ramp gets lower. So as height increases, the time decreases. Therefore, this is inverse variation. And one thing that we need to note here is that there are two situations where nothing is going to actually happen. And that is where our ramp is standing up, or our board is standing up perfectly tall. And imagine a ball of some sort sitting at the top of that. It's not going to go anywhere. It's going to balance. Okay, so that means that there would be no time in this situation. That is an undefined slope. That is what we call an asymptote. Another situation we need to think about is if the ramp was laying flat on the ground. In this situation, if there was a ball, it's also not going to go anywhere due to the fact that there's no slope to move it forward. Also an example of an asymptote. So that's where our horizontal and vertical asymptotes come from in inverse variation functions. Now the next example wants us to look at some data and decide which one is direct and which one is inverse. And it does say that the constant variation is the same for the two relationships. So when we're looking at variation, we want to look at how we get from our x values to our y values. So when I'm looking at these values, I notice that I'm getting smaller each time. And that would tell me that I have likely some form of division. When I look and think about what numbers I can divide, I would start with something that is showing a denominator. So if I think about my y, it would be a number over x. So looking at the third one, I have 2. Let's try that again. I have a 2 over 3. Well, okay, if I put 2 over 4, that does reduce to 1/2. 2 over 5 works. 2 over 6 reduces to 1/3. 2 over 1 is 2, and 2 over 2 is 1. That means that my constant of variation, which we call k in this situation, is 2. Now if we look at the next one, and what we have to do to get from one to the other, that's very easy to see that we just need to multiply each thing by 2. But since we're multiplying here, we've got to think about the fact that this is going to be direct variation, because I can say y equals 2 times x, and the previous one would be inverse, since we can say that y equals 2 divided by x. Alright, and the last examples are some real life situations where we want to solve some problems. So it says the time it takes to paint a house varies inversely with the number of painters. If 3 people can paint a house in 7 hours, how long will it take 5 people? So what we want to think about here is that you've got 3 workers. And I'm not an artist, so bear with me. Okay, so 3 workers, and each of those workers is working for 7 hours, because it's taking all 3 of them 7 hours to paint a house. So that means that in total, they have painted for 21 hours, because the 3 painters have painted for 7 hours each. So they've done 21 hours of work. Okay, 21 hours of work. Now we want to figure out how long it's going to take 5 people. So I want to add 2 more into this. Well, if I do that, then I don't need these first 3 to work a full 7 hours, because really I can have the job done in a total of 21 hours. So what I can think about here is that 21 is my constant of variation. That is the number that I need. And if I divide that by my number of workers, I should get how many hours it takes them. So 21 divided by 5 is 4.2. What this means is that it's going to take 4.2 hours for 5 people to paint that same place. What our equation is here is y is standing for our time, and x is standing for our workers. Okay, so our equation was y equals 21 over x. The next one says the number of gallons of fuel used for a trip varies directly with the number of miles traveled. A trip of 270 miles requires 12 gallons of fuel. How many gallons are required for 400 miles? So here we have direct variation. So we know that we're going to have some equation along the lines of y equals k times x. What we have to decide is what our variables are. And what we know is that we have 270 miles. We'll put that as my y, equals k times 12. If I divide by 12, we're going to get a K value here of 22.5. What that means is that we get 22.5 miles per gallon, and that is our constant of variation. So to figure out how many gallons it's going to take for a 400-mile trip, we're just going to plug that in. 400 equals 22.5 in this case times X, which are our gallons of gas. So when I divide 400 by 22.5, we get that X is equal to 17.8 gallons of fuel. And that is a direct, where our previous one is inverse. And that concludes the Ramp It Up lesson.